So thanks for coming on this Friday afternoon. Really appreciate it. We're excited to be here. I'm Patty Ryan, joined by my colleagues from the CSE group, Stott and Michael Lanzetta. We work on prototyping, coding with customers and partners, and creating prototypes in open source. One of the really exciting things about this conference is that we share that mission, I think, with a lot of people here. Ferdinand Perez gave a great quote at the keynote yesterday, which I really loved, and that was that the thing that brings us together is we're all building weird things that cut across the grains of stuff. And that's exactly what we do, and that's exactly what we want to talk about today. As I mentioned, we lead prototyping, and Jupyter Notebooks are key to the way that we work in our prototyping with customers and partners. It allows us to work across geographies, across organizations, across teams, and even across time by documenting our thought processes for handoff for others. So we're excited about the opportunity to share with you 4 stories that we have from industry. And we have a GitHub repo with all of the notebooks in it. Because we only have 40 minutes, we're going to go through this relatively quickly, so I'd invite you to look at that repo linked at the bottom of this slide. You can even look at it as we're going through things, since we'll go relatively quickly. And if you have any questions or want to talk about any of these things, we'd encourage you to reach out to us, and we'd be more than happy to engage. So we'll start out with retail with Michael Lanzetta.
Actually, we're going to go a little bit into
yes. Oh, I'm sorry. Yeah. So thank you. So we're covering a range of technologies and architectures, and each of the notebooks that we have kind of highlight pieces of these. And Lee's going to take us through that.
So hi, I'm Lee Stott. So I just want to try and set the scene, because I think everybody's from different industries. So how many people in the room are from a corporate industry? How many educators do we have? And then how many like startups or pure data science people working in open source, etc.? So a good mixture then. So this is typically what we see as an architecture overview when we go into any organization. We have at the bottom people are using on-premise servers. So you've got data science machines, storage servers, there could be containers, there could be VMs, there could be physical boxes under your desk, which are generally running Jupyter Hub and data science tools. And again, you might have data that is secure to your organization, so it's always going to be on-premise. On the left-hand side, we have like our new containers and cloud services. So they could be in Rackspace, it could be Azure, it could be Google, it could be AWS. And what we're trying to do there is look at how we can provide data and services, which really what we call a hybrid solution. So with Microsoft, what we have is we have Azure AD Connect and ExpressRoute, which allow you to create secure VPNs from your own data center directly into cloud service data centers. So you can have data on-premise, data in the cloud, and then we provide services like the data science virtual machine, which is a pre-built virtual machine, either as a container or as a VM, which has R, Python, Anaconda, Jupyter Hub, all the software that you will ever need, pre-configured and available. So within 15 minutes, you can have a full working data science infrastructure. And then we have all the tools to allow you to connect that back to your authentication services. So if you're using Google, OAuth, AD, Microsoft services, it doesn't really matter what you do. We can connect that back so you can have single sign-on from any user on your premise to those servers. And that, again, becomes really important in terms of that manageability piece. You don't want to be creating hundreds or thousands, if you're a university, user accounts per year or per semester for all your users. You want to provide single sign-on. Again, when you actually look at all these different services, the key thing is really going to be around the authentication and management. And then that allows you to do the sharing. As Microsoft, we also offer a service called Notebooks at Azure.com, which is a completely free software as a service offering of Jupyter. So you can go to Azure.notebook, sign in with a Microsoft account. If you've got Office 365 already, it automatically signs you in. And you can develop and provision notebooks. Again, we find that really useful in educational context. And we've got some more details on the architectural scenarios at the link at the bottom. So again, if you want to read a bit more around this and find the documentation and get access to the repos and the case studies that we've already built, they're all available there. The next thing we want to look at is how the orientation of notebook narratives actually happens around a technology aspect. So as we said, you might be on premise, you've all got a laptop or a desktop which you complete and undertake your Jupyter Notebook development on. And then you can either go to on-premise, as we've said. So again, it could be data, it could be services, it could be IoT devices that you're capturing all this data from. You then got some form of cloud, hopefully, where you're looking at Kubernetes, Docker, and then services like CMTK, TensorFlow, ML Spark, all those different data science services, so HD Insight, which could be run as a cluster environment. And then what becomes really important is the source control aspect. So I think everybody's talked about it during the last few days, is that if you're producing notebooks, you want to collaborate. You want to be able to share those, whether you put them on GitHub and you use things like Binder to view them, or you have them as a repo, which is just source control for your end users, so people aren't overwriting other people's work. So as Microsoft, we've got VSTS, we've got GitHub, we've got Git integrations, and again, we've used this internal in our own services. And then what really makes notebooks attractive and exciting is bringing in those additional cloud services. So some of the key things that I always talk about is a thing called cognitive services, which is being able to bring in special APIs, such as the Face API, and we'll talk about those in a bit more detail later on. Using software as a service approach, like Azure Notebooks, you might want to publish both from an external or internal perspective to something public, and then understand who's utilizing those notebooks, so the ability to clone the notebooks and then use them for citations in an academic context, so it could be just a share context if you're in an industrial setting. And then also getting access to data. Data is really key. You've got data in the cloud or data from services like Kaggle. You want to be able to join those to your data science experiments. And then what's really important to us, and I hope you all find this really interesting as well, is we have a service called Cortana Intelligence Gallery, which allows you to share your complete experiments and data. So you can make them a community-based project and share your experiments with other people within your areas. Again, that can get citation and references if you're from an academic context, but it allows you to have a formal publication process of your entire research.
So I just wanted to talk you through one of the cases that we did as a team, and this is in the retail space. And we were working with a partner to determine if we could help them with their inventory management issues using deep learning. So the particular problem we were running into was we had a large European confectioner who came to us, and they wanted to figure out if they could improve the process by which they found whether stores were adhering to their vendor policy when they were stocking. Because the way it currently worked was very manual, very painful. They had people go out to the individual stores, take pictures of the shelves, manually assess the shelves, and send them back to headquarters to see if the individual shelves, turn that off, individual shelves had problems or if the whole shelving unit didn't adhere to policy, and they were wondering if that was possible to improve using some sort of deep learning method, either in the cloud or on the device. And we find Jupyter Notebooks to be really handy in these situations. What we did is we did a one-week hackathon with this customer, or Hackfest with this customer, where we sat down directly with their developers and developed with them hand in hand. And Jupyter Notebooks are pivotal in these sorts of situations because it allows us quick iteration. We can iterate very fast. We can easily document all of our assumptions much more easily than we can in just source code. We can give markdown, we can give actual equations, we can really set out exactly why we've set the appropriate learning parameters that we've done, things like that. And then at the end of the hack, we can consolidate our results into one or more notebooks and publish those internally to the partner, as well as our group. We ship almost everything we do open source, then we can publish it on GitHub as well and have that out there for people to look at. So in this particular case, the problem was whether the shelves were correctly stocked. And what we had is we had a lot of domain expertise within the partner where they were very knowledgeable on this shelf-by-shelf visual inspection and on whether the overall shelf composition as a whole made sense. And what we needed from them was data, right? Any deep learning model needs a sufficient amount of data in order to be useful. And so what we had is we had them label several images. They labeled about 1,000 images. And we use this tool that we've also developed as part of our team called the Visual Object Tagging tool that allows you to tag images or videos with labeled bounding boxes in a very quick and easy fashion. And it's AKMS VOTT. It's all open source. Feel free to download it. It's built in Electron, so it runs on everything. And it allows full round-trip training for CNTK currently, and we're adding TensorFlow support because we don't care. And the way that we chose to do it in this particular case was we used an algorithm called fast RCNN, which is a deep learning method for being able to do object detection. And object detection is one of the classes of deep learning models that exist. There's image recognition, where you have a picture and you go, this is a cat. And there's object detection, you go, here's the cat in this rough bounding box. And so that's what we were doing, is we were solving that particular problem. And fast RCNN at the time was the best. There are better ones now. So just to go into a little bit of detail about fast RCNN, as you might guess from the name, it's faster than regular RCNN, but it's slower than faster RCNN. I know, weird, right? And this is all within about the space of a year. There are now things that are even faster than that. Oddly, they didn't call them fastest RCNN, which I'm still expecting. And the way this works is you have this model that takes in an image, a set of region proposals, so this might be where the bounding box is, and a set of ground truth that says this is exactly where the bounding box is. And you train that model, and the way that you train it is you take an existing model that's been trained to solve that image recognition problem, this is a cat, and you rip off that last layer that says, I'm 80% confident that that's a cat. You destroy that, and you just keep the layer before that that says, I have some real knowledge of what these high-level features are of an image. Like this is what a cat's ear looks like. This is what a dog's nose looks like. It knows all of these high-level constructs, and you build more layers on top of that. And those layers on top of that, one of them basically is another judgment layer that says, I think that this is what this is. And another is what they call a bounding box regressor, which says, you've given me a proposal for where that bounding box might be. Actually, you should push it over here, right? It basically is pointers to where that bounding box should actually get pushed to. And so you train that using a process called transfer learning, where you lock down the initial weights, and then you only train the rest of the layers that you've added. And that allows you to basically get up and running with a lot less data. Because if you were to train this from scratch, you'd probably need a good, at least 100,000 images. And in this case, we only had 1,000. And so we actually got reasonable results with 1,000 images, enough that it looked promising and we could send them on their way. And Jupyter Notebooks were incredibly pivotal here because it allowed us to focus on that problem and allowed us to get the pipeline in place and then deliver that to both the customer and to GitHub so that people could use it and then write up a code story on it and share that with the community. So just to give you a sense of the actual Jupyter Notebook involved, so this is, let's see, Control+. This is a Jupyter Notebook just for doing the evaluation. And I'm not going to walk through in a lot of detail because, once again, this is all on GitHub. But basically, what it's doing is it's loading up this pre-trained model that's been trained earlier. And so this model may have been trained on a GPU cluster. We actually trained this on a Kubernetes cluster that we had. And you can see here is the initial image, which is the refrigerator. And if you go down here, you can basically see it's detecting a bunch of regions of interest and then figuring out what the labels might be. And it actually does a reasonably good job. It finds the booze, it finds the juice, it finds the yogurt. It misses the egg carton, but it does reasonably well. And so this is on groceries, and unfortunately it's not on the partners' images because they would not release their images, although they did allow us to release the code. So this is just one example of the kind of work that we do. And now I'm going to hand off to Patty to talk about some work that she's done with Ernst & Young.
Great. So switching gears quite a bit to Ernst & Young, professional services example. So what Ernst & Young is trying to invest in is expert systems. They have a large staff of accountants, consultants, who need to make sense of large corpuses of documents that their customers have, and those documents sit in many different types of repositories. And actually finding the right information and reasoning on that information uses an enormous amount of their time. So what they're interested in is an expert system that will automate that step. And of course, central to that is search. So what we worked with them on is a custom search experience And in so doing, we kind of took their corpus of documents, cleaned and extracted the right metadata, augmented that metadata, and then tweaked Azure Search, although you could use other search engines. We tweaked Azure Search to get the very best result in line with their performance requirements. So let me, in the interest of time, I'm just going to give you a quick flyover of that. Let's see. Okay, there's a notebook here. I'm hiding some of the code, but let me give you sort of a little bit of the process and the tools that were involved. So in the gray boxes across the middle are the processes that we went through to create this custom domain search engine for EY. Of course, there's the pre-processing of the content and source enrichment, and that's, as anybody who's worked with text in the wild knows, is an enormous amount of time and energy. We have all of the utilities in this notebook that you can leverage. We tweaked the custom analyzer, did some custom scoring. We actually put in some acronyms, and out of that we measured the results. And one of the other offerings we have is iterative measurement. Because as you're developing these, of course, you're measuring it to the standard that your customers are requiring, and the UI that you're going to be delivering this within, if you're going to be able to deliver 5 results or 3 results, or if you just need to deliver the one best result. So there's a whole set of information in here. This diagram gives you a little bit of an overview, including an interactive testing script at the very end. So I'd invite you to have a look at that. And let me jump to the next vignette. And this was from our work with the Professional Ski Instructors Association. This is a sports example, of course. The Ski Instructors Association, what they're trying to do, of course, is to, it's sort of similar to EY's mission, what they were trying to do is to allow their instructors to be more productive. And today, the instructors have to be there, of course, physically with the skier to provide instruction. They wanted to have a way for them to codify the actual skiing behavior and performance and to provide feedback on that. So we worked with them. We used a set of wearable IoT sensors, and let me talk you through the data that we were pulling off of that. So in the keynote yesterday, Deborah Ma talked a little bit about a similar scenario, so I was so excited because you've seen a little bit of this already. And the process that we applied was very similar to the one that he applied. So if you see in the bottom left corner, in the green are the sensor position information that we used. So we're actually gathering sensor data from more positions, but those were the only ones that actually were vital to us in telling us skill distinction and skill differences between the levels of skiers. The information coming off of the IoT sensor, of course, you've seen this before if you've looked at any IoT sensor. This is all the typical stuff, the XYZ positional, the rotational for the 3, and then the acceleration. And if you lay that against a time series, as Demo was talking about yesterday, you get something that looks a lot like a signal. So we used signal processing techniques to crunch this a bit. The PSIA wanted to understand how to help instruct the students a little better. So what we did was we put the sensor, gathered data from professional skiers, expert skiers, and then compared the intermediate and beginner skiers to that kind of gold standard professional set. And in order to do the comparison, what we did was we took these sets of data. So this particular time series that you're looking at is one run for one sensor. I think this was the left foot sensor. What we did was we took this and generated engineered features. So these features characterize the differences that the ski instructors knew to be present between beginners and intermediate and professionals. Things like leaning into the mountain versus standing up, being erratic, having even feet and leaning into the mountain. So we created a bunch of features, and you'll find that all in the notebook. We also summarized this data in 2-second intervals. So we took each of these 2 seconds, we generated frequency statistics and also did Fourier transform statistics on each of these. And what we found, let me show you the notebook. What we found when we did that was that actually you could characterize the differences quite starkly, quite distinctly between the professional and the beginner, on the positions of their body and against those domain identified kind of best practices. So the upper box here is the engineered feature, which was trunk twist. And so trunk twist, let me show you that. Trunk twist was a combination of sensor values where we calculated the plane between the upper legs and the upper torso and the amount of twist and crunch in that torso. And you can see here that the professional skier on the right is far and away greater in terms of their crunch and incline into the mountain versus the beginner on the left. And when we took any of these 2-second intervals and looked at these sets of features, we could classify with amazing accuracy and precision the data coming off of the professional skier versus the intermediate. This is the confusion matrix and AUC curve here. It's almost incredible. So what we've done is we've put this data up. So we invite folks to play with this data. There's so much more rich information there to be mined, and we would love to work with folks who want to help us explore this a bit more. The PSIA, of course, is interested in developing these kind of sensor-based instructional methods. So with that, oh, and I should say there is, in the notes here, we have this full experiment is up on the Cortana Intelligence Gallery for you to download and replicate. There is a full GitHub repo with the data linked into it and a code story. So I'd invite you to go up there if you're at all interested, and I think it's fascinating. I think you would have a lot of fun working with that data. So next off,
Hi, so I just want to cover some educational scenarios. So I've covered this earlier on in terms of the typical infrastructure for students. So students generally have provision to bring your own devices or notebooks or PCs provided by the institution. Again, they typically access data now within the cloud. So I think Berkeley's done a lot to show us how they've been heavily utilizing cloud services over the last few days. And again, that's either via SSH to VMs or to containers. And then they undertake Jupyter Hub via URL and undertake Jupyter Notebook development. And again, access data both on-premise and in the cloud. What I want to do now is actually look at how some of these case studies, so Berkeley has to be shown again, sorry everyone. But it is an amazing story of scale and support. So we've been working extensively with Berkeley for the last few years looking at how they've been deploying their infrastructure and services. And we've worked closely in terms of starting off with virtual machines and look at the data science virtual machines, and now they're actually helping us with Kubernetes and the Azure Container Service and working directly with our engineering teams to ensure that the service is scalable and supports educational users worldwide. And again, as you've heard from a lot of the sessions today, we want to really start sharing this as a community-based project to help other universities and other institutions deploy large-scale services to their institution. So a quick video
of the actual process. How can we make it available and accessible to the entire undergraduate population? That's a question of scale, but it's also a question of accessibility.
What we wanted to make sure didn't happen was that students would get bogged down in learning how to install software.
We had issues with the audio before.
Or that kind of nitty-gritty of using applications that are just difficult to work with.
By hosting it in Azure on a single Jupyter Hub instance, we can control the environment. Students don't have to install anything. They just log in and they're ready to go.
We're a very diverse group. The students are from about 60 different majors and about 85 different combinations of majors. It is important that everyone gets to decide what data should be analyzed, or what questions should be asked of the data.
Using the skills of data science, I'm able to look at these questions and be sure that I'm doing my best to conduct good science by using these tools to really understand the data and what it's doing.
So the key thing around working with universities is, number one, academics typically want to be academics. So who's an academic in the room or a researcher? You don't want to be DevOps guys, do you? You don't. And you know, it's really important that people who are experts in their fields become experts in their fields and maintain experts in the fields. So what we try to do with lots of institutions is take that DevOps burden off them, either by allowing them to use software as a service models with Azure Notebooks, or using the data science VM that I mentioned earlier on, so they can quickly deploy, create single sign-on for all their students. Their students just log in, they have the notebook repositories and services that they require for their research, teaching or learning, deploy their works, take a backup, whether that's in a GitHub format, whether it's in a clone format from a notebook service, or whether it's in a gzip tar, which they can take to whatever the service they want to do in the future. Some of the work that we've been doing recently is looking at curriculum which is typically not STEM-based. So who doesn't teach STEM subjects? Anybody teach things like music? So Carol did a great presentation yesterday on Magenta, which is a TensorFlow music service. What we've been doing is doing some work with web developers and with translation, so with linguistics departments, using Microsoft Cognitive Services and notebooks. So the first example I want to show is using our Face API detection tool. So it's a free service from Microsoft Cognitive Services, which allows you to detect and examine people's faces and give identification services. So this is all running in Azure Notebook Service. It's, again, a completely free service for anyone. All you need to have is a Microsoft account to sign in. And what I have here is basically a set of Python notebooks. The notebook service currently supports Python, R, and F#. You do get full terminal access. So you can see there's a terminal window. So I've got a full bash terminal window here. And also, what's really great is you can pip or conda any implementations into your notebook service. So what I want to do is quickly show you these notebooks. And the first one I'm going to show you is Cognitive Services using Translation API. And this is just a proof of concept that we've been working on with some linguistic departments, looking at how they can use notebooks to really improve the standard of their linguists, and also give scalability in terms of linguist assignments. So this could be taken all the way from a high school level all the way up through a university level. So what we basically have at the top of the notebook is a simple import, and I think this really came out of the Birds of a Feather session last night about scaffolding and being able to teach students quite quickly how to build notebooks and document notebooks in terms of learning pedagogy. We then specify a key, so I've left all my keys in these notebooks, so please don't do 2 million transactions, because that's my limit, because you get 2 million transactions for free on character recognition. But you can actually have a play with this, it's live. So basically I'm calling my key, I'm calling the Cognitive Services, it's then doing a validation, it's bringing back my key, and then I'm doing the translation. So at the moment I'm just doing French to English, so I've typed in some French, I've set which language the actual statement is in, so it's in French, and I want to translate it to English. And then I've added things like BS4 and colour just to really give some syntax output to the end user of what the output is. So it does this is what you said in French, this is what you said in English. So very, very simple, very, very straightforward, but massive scalability. So if you think about this from a learning pedagogy, what could you start building into these notebook learning experiences? So is it male, is it female, etc. You know, so you can start just building some really nice syntax pieces. The next example is using Cognitive Services to do face detection. And as I said, this has really been aimed at web developers to teach them the foundations of JSON. So this again does a simple import at the top. I've added in things like the MB extensions library, because I think, you know, doing flattened headers, etc. is really cool. And And again, what we've done here is just got 2 demos. So I've got a demo of Taylor Swift. So if we just open this in a new window. Oops. What's happened there? We'll do the picture of Donald Trump. So there's a picture of Donald Trump. Everybody knows who he is. And what we've done here is basically loading in the picture. We're doing some analysis on it, so it's basically capturing the facial features. It's saying the emotions of the features, and then it's bringing back a JSON response of what the actual picture is. So you can see it's got, you know, low-level blur. It's currently saying that he's quite angry, so he's 50% angry. I'm not US, so I can say that. It's saying it's good exposure. It's saying it's a male. He's wearing no glasses. It tells you the hair color. It tells you if he's bald. It thinks he's quite bald. And again, it does a head pose and a frame of what the actual image is. And again, on the Taylor Swift one above, you can see that it's actually identified her as a female. Again, no glasses, good exposure. So again, you can start taking this on. So you could easily take this to the next step, saying, okay, I want you now to build a Python command that says, how happy is that person? Are they happy? Are they sad? Do they have fear? Do they have emotion? And again, just keep building that pedagogy through a notebook for an end solution. And then, you know, the final solution could be, let's create a face API detection tool that says, is it you or me? So again, very, very simple methods. So the next example is the University of Cambridge. So the University of Cambridge had the issue that most academics have in this room. They had Jupyter Hub installed on premise, and they were rapidly scaling their engineering and mathematics curriculum, and they wanted to use Jupyter for all their undergraduate teaching. So they have 350 students in engineering who all do a combined first year, and it's all taught in Jupyter. So everything's done in Jupyter. They had massive issues of management, maintainability, creation of user accounts. The academics were, you know, wanting to do prep over summer and not build virtual machines and manage virtual machines. So we worked with them extensively over the last year, moving their entire services from on-premise into the Azure Notebook service. And the key contributor behind all this is Dr. Garth Wells. So if anybody knows the Phoenix project, so Garth is one of the leaders of the Phoenix project, massive open source contributor, you know, there's lots of work in this area. And he's had some amazing comments. You know, you can see the comment here about what he's thought about Jupyter and Azure Notebooks and how it's rapidly enabled him to deploy to hundreds of students. And more importantly, allowed those hundreds of students to be able to learn 24 hours a day, 7 days a week. He doesn't have to worry about his infrastructure going down at weekends, or is it going to be patched? Does it need to be maintained? Does he need to add a user account? So I had a quick interview with Garth, and this is what he said about open source.
First, with my research, we've become much less reliant on centralized IT services. And that's really been the advent of services like Bitbucket and GitHub and all these cloud-based services which can actually provide products at a level that no one institution could even get close to, in that the rate at which they innovate and the quality of their products has just put everyone else in the shade, and it's really quite remarkable. And then in a way we're following up now with teaching by moving to the cloud-based services, because out there is the skills and the expertise and the willingness to provide tools and infrastructure that, despite all the willingness in the world, that local IT departments just really couldn't match. You know, they might be stretched for resources, they don't have the breadth of expertise, and they just can't match the rate at which some of these other products are developing. And the ability for users to feed back into these products as well and have them develop. The idea, again, with these public issue trackers where anyone can throw up their idea, and then if there's support for it, that it happens. And the speed can really be breakneck, and that's something which IT departments, I think, locally will really struggle. In many cases, it would be impossible for them to match.
So, you know, the key comment which we got from that was the ability to do issue tracking, and that's where Azure Notebooks is really great. It's an open source project, so it's on GitHub, and you can actually just make an issue. So, you know, Chris sat in the front row, he's already been doing some issues today. If people want services added or features added, there's an issue tracker, and you can actually track the progress of where that issue is up to. So again, we're trying to work with you as a community to build the best tool for you as individuals. So in terms of demos, this link actually goes off to the entire notebook repository for Cambridge. So if I just show you what is available there. So what happens, this is actually Garth's main library page. So what is really great about notebooks from an academic perspective is each user gets a library profile page. So this is your personal profile. You can have, your picture on there, your contact details. It has all your libraries. And what's really interesting about this from an academic context, it shows you how many people have cloned it, and it allows you to track who's been cloning your repos. So if I just go into all Garth's libraries, you can see here he's done his maths undergraduate curriculum. So this is the entire mathematics undergraduate curriculum at the University of Cambridge. Again, you can see it's had 300 odd clones, and each notebook is fully documented. And more importantly, this is all available under MIT licensing. So you can download, clone, reutilize this to your heart's content. Again, he's done the same for computing. So this is all available. Again, it has GitHub, it has issues. If you want to start modifying, adding to this, you can do so as well. So we're building out these portfolios for each of these academics. And again, it's a citational tool that allows you to then record who is utilizing your services. So as a quick recap.
Yeah, so I just wanted to close with eventually some questions, but I wanted to say that one thing that we really love about the Jupyter community is it's very supportive, and it's incredibly useful for our the kind of work that we do. We're definitely committed to Jupyter and to both Jupyter Lab and Jupyter Hub, and we see that that's going to be really pivotal going forward, both for this kind of quick innovation work that we do, as well as this collaboration work that we like. And so I'm really hopeful that that next year we'll be able to have some really interesting things to share as well. So I wanted to close if you had any questions about either the work that we've done or how we use Jupyter in the wild. Thanks.
Any questions?
Yeah. So the question was about reusability of pieces of the work that we do, and particularly in the case of work that's in Jupyter Notebooks, how we manage to reuse it, and are there any best practices? At this point, I mean, we definitely do have reusable chunks of code that we reuse. We don't really have any best practices in place, at least amongst our team, other than having common centralized repos where a family of repos where our stuff is submitted. And then sharing kind of best practices and having an active community on Teams.
So just to add to Michael's comment on that, one of the key things that we found about Azure Notebooks is that the ability to produce your notebooks as you would do normally, put them on a GitHub site, and then what you can actually do now is import directly from GitHub into Azure Notebooks, do a clean, do a refresh, and then that is your portfolio that you want to share. So that's probably one of the key scenarios we see at the moment for the ability to consolidate and share.
Yeah.
In the last section, you showed a bunch of examples of working with different academic institutions. They're mostly colleges that are teaching their coursework. Do you expect to sort of continue that expansion at the collegiate level, or do you expect to see more stuff sort of going to earlier education?
So it's really interesting. So part of my role is academia. So we're starting now. So does anybody know about the microbit? Anybody got children seen a microbit, which is a little embedded device, or Raspberry Pi? So we're doing notebooks to devices at school level, so 6, 7-year-olds, all the way up to notebooks in education for graduate level. So we're going across the whole panacea. So we're seeing more importance of sharing from top level to bottom level, etc. So every level, and we see notebooks being that key driver. And we're doing lots of work in the notebook team to make sure we can get some visibility in all those different aspects. One of the other key things that we're doing is moving tryfsharp.org entirely into notebooks. So you can do the entire F# curriculum in notebook environment. So
we have 1 minute left.
So we've got 1 minute. Any other questions?
Just a quick question on the microbit thing.
Yeah.
Any links that you could send?
No, so we're working on it at the moment. So I know it's only just been released in the US, so yeah, we will have stuff over the summer.
Thanks so much.
Well, great. Thank you so much.